cheaper, but or alternatively you can pay extra for additional electricity line.
So what was the conclusion?
So it was laptops and schedule of workers. So
really?
Yeah.
That's incredible. I've never heard of such a thing. But only in Ukraine, right?
Yes, it's Ukrainian.
Right. Sorry, sir. Somebody else in the back had an example.
We actually had a traffic model, and we had to calculate the optimal traffic routes for cars. And there were many, parameters like the volume of the car, how many customers in the region, the time is window, time window when it would come to the customer. And also it was very complicated because you could deliver the goods or and you could take the goods from the customer. So you have to calculate different kinds of parameters.
So did you have a model that you used for that, or did you use raw data from the traffic?
Actually we had a model, but it was too complicated, so we actually, at the very end, we had to make separate cars for delivery and separate cars for taking out there, and we also had to separate the city into different regions, so the cars working it's not like small regions, not the whole city.
One thing to say about, say, optimization, right, and Jaroslav, you can correct me, I'm not expert, but you can look at a function, right, let's say we look at this function, right, and basically what you're trying to do is to find a minimum. If you know the derivative of the function, it can help you get there faster, for example. Numerical optimization can be tough because it's noisy, right, and you can get set up in the wrong direction. Who else has used optimization? Please.
We use the optimization to find out the optimal coverage of the surface. So we want to extract data from Foursquare, and we need to, with their restrictions, we want to do as much as possible in short interval. And with no optimization, it was like we need to reduce the amount of queries about in half.
Right.
To get all the data, actually it was a model, but it was like.
You use part data, part model.
No, we designed that. We
Right.
designed that, we test that,
Right.
and we implement that, and it was really close to the optimal.
Right. So you would say it was successful?
Yes.
And you would say it was successful? And you would say it was successful? Yeah. Okay. So optimization is used a lot, especially under constraints, right? Because life has got many constraints. And if you don't know much about optimization, I suggest you take a look at it. You can practice it. There's many routines out there that can help you do that. Okay, so I don't even know what this means. I think Jaroslav, can you explain this to us?
The different types of optimization problems. So they can be in linear form, and they can be like if you use only integer numbers, so it would be integer programming. So because it's much easier to work with continuous data than with integers.
Right.
And some solutions might be easy for continuous, but you can't have half a person.
Right.
So therefore you use this integer programming, and others. So quadratic programming means quadratic form of optimization function.
So we'll continue. So more examples. Quite often, really, nuclear reactors, the optimization of nuclear reactors, especially the moderation, can be a really big important thing. And as Chernobyl demonstrated, you better have that optimizer running. And then we can look at, here's kind of, this was an example I gave for another class. Yeah, we don't need to go through this again. But I like that book.
Yes.
So here we have, the typical example of an optimization surface. You would like to have just one minimum. So this is, let's say, the amount of water in the Samahon. This is the heating rate. This is the flow rate. But more often than not, you'll see a surface that looks like that. And the problem is you have these local minima, and you don't know what they really mean. They're better than being here, but they're not. You might be stuck here, and yet there's a better one there, and you don't know it. There's no way of knowing this. There's many techniques to try to, so for example, you find the local minimum, then you step out by some known factor, and you go in a perpendicular direction. There's all kinds of ways to do this, but they're empirical. There's no closed form for it. Machine learning. Who does machine learning? Essentially, with machine learning, what you're doing is you're giving a machine a lot of data, and you're telling it, use these different functional forms, but you decide how it all works. You teach it questions and answers, right? And so it's called training data. And you will not understand by the time the machine has created this algorithm, you will have no way of understanding what it's done. But it will get you a solution. So, for example, you could say, how do I optimize the tax output of Ukraine? It will look at years of something, it will look at years of how old people are, how much tax they generate. It will look at the GDP, it will look at how much tax, it will look at all kinds of things. And you will give it some set of functional forms. You say, try exponential, try quadratic, try this, try that. And it will look at all of this, and it will just keep working until it optimizes the relationships. It minimizes the difference. So, for example, it's often used in black boxes in these hedge funds, in trading stocks. In this case, Google is using it to better design data centers. Let me ask you, do you know how much energy is used in data centers? What percentage of all the energy in the United States? Anybody? 2% of all the energy is used in data centers. So, to give you an example, if you look at the energy you use in the house, in the US, it's about 3 or 4 watts per square foot. In a data center, you can be 2,000 watts per square foot. It's a massive amount of power that's used for computation. And usually you use as much power for computation as you use for cooling. So a lot of these data centers are being built near large bodies of water for that cooling. So let's see how this works. Where'd it go? Does it have audio on this? It's all right.
But cities can be hard on forgiving places to live. And I'm not just talking about the dating scene. Cities are tough because they require us to live on their terms. But in 5 years, the tables will turn, with cities adapting to our terms. Through cloud-based social feedback, crowdsourcing, and predictive analytics, we'll shape our cities to our evolving wants and needs, comings and goings, and late-night pizza and breaks. By engaging citizens, city leaders will be able to respond directly to our needs and dynamically allocate resources and pizza. Systems will connect billions of events in real time to anticipate movement and react to human preferences, patterns, and demand. For example, instead of buses running on fixed schedules, monitoring systems that might predict storms during rush hour will anticipate more riders and dispatch more buses. Through our devices, we'll develop an intimate relationship with our cities. We'll use our devices to do everything from report pothole to discover an underground show. As we speak to our cities, they will listen and become a direct reflection of all of us who live there.
So, do you remember the task I set you all? Who's done it? Very nice. Begin the double business first. All right. So, what we're going to do now is we're going to go through the audience, right? Can we lift this up a bit? Let's go talk about big data. Okay. let's get some examples from this class, from the work that you do, from the ideas that you have. Let's work on this a little bit together, okay? So we said we were going to. Servetku, dobro. Počnemo zadu. Hajde Vasil. What is big data in your mind? Let's take some What example would you give of big data?
Масив даних.
Give us an example.
Масив даних, які мають показник простору і часу. Окрім того, що вони мають якісь значення.
So, дайте предмет.
Знаходження людини у просторі і часі. Будемо в якийсь момент.
Let's look at this. So let's say a emergency people location, okay? Следующий.
Тарас.
Тарас.
As an example of application of big data, right?
You can do both, an example of application or the data itself.
Well, I think in image recognition as a...
In what case? Let's go beyond just image recognition for what?
Cancer.
Cancer? Good. You agree, Taras?
What is data?
Or terrorism prevention.
Okay, good. Okay. Image rec for terror. So for example, here's what I heard today. I heard that the Russians are putting noise up to kill the GPS satellite data. And our guys are going out there using image recognition to help the drones know where things are. Good. Go ahead.
Insurance companies are using a lot of data.
I'm sorry?
Insurance companies.
What kind of data would you say? What is it?
If it's life insurance, they're using health
Okay,
data.
mortality data, mortality and health. Good, good. Health, mortality. Okay, let's keep going. Rosh.
I'm thinking about some climate disasters or something of that kind, but I'm not sure what data should be used for making such kind of forecasts,
So,
predictions.
weather forecast for disasters, right?
Something of that kind.
Large data for weather data, right?
Yeah.
Good, that's good. Now, let me point something out there. So with the weather data, normally when they do weather predictions, they do over a 40 kilometer by a 40 kilometer area, right? And so that's a rather large area. If you could do weather prediction over a 1 by 1 kilometer area, you could do something a lot more sophisticated. For example, pizza companies sell 30% more pizza when it rains. And they sell twice as much pizza when there's a storm. Why? Because Domino's delivers. So if you know what the weather's going to be, you can change your business. So weather is very important, and as you make it more dense, so there's more data. Proszę, dziękuję.
Well, maybe trading companies, when they
Trading.
trade different goods,
Right.
when they get the information when something might be needed at some point.
So commodities trading, you
Yeah.
think? Yeah. Commodities trading. Now let me ask you that. If I'm trading commodities, right, what's important? What kind of data is important?
I think maybe Maybe also climate data might be in
Climate data.
for that
Yeah.
used, because you have to know what weather conditions were,
Absolutely.
if they gathered enough
Absolutely.
frost.
So in commodities, every piece of data is important. No, seriously.
Seasons.
Seasons, politics, laws, weather. It's a, you know, in commodities, most people are like this. No, seriously, they are. The commodities traders, they think they're geniuses, right? But it's a tough game.
Mm-hmm.
So if you look at really where a lot of people have made money in commodities, I would say it's where they have had inside information.
Mm-hmm.
Ross,
Okay. Probably the historical data on, say, e-commerce websites, so we can prognose inflation or whatever.
So this is purchasing data, would you say, or this is
Right.
supply data? Which kind of data?
Supply data.
Commerce supply data. Okay, let's see. What else we got? Go ahead.
Probably some healthcare data from persons that are using some personal devices to predict symptoms, for example, mental illness.
Okay, so you want to use data from mobile devices to predict mental health, yeah?
Yeah, because there's changes in behavior.
Behavioral data from mobile devices. Yeah, let's go. Go ahead.
Maybe some data about conditions of agriculture crops.
Okay.
This could be weather related also.
Yeah. Crop data, right? But Rosh.
Can be social data.
Like what?
For example, every time you log into somewhere, you are allowed to use, for example, your Facebook account, your Foursquare account, whatever account you
Right.
want.